Okay, this video we're talking about perpendicular and angle bisectors. This sheet usually came with the Prentice Hall geometry 5-2 section. So let's look at number 1 here. They want us to talk about the relationship between LN and MO, and we can't see it, but that's point in there. So LN and MO, they cross at right angles and they're bisected. So LN and MO are perpendicular bisectors of each other. Like LN bisects MO, and MO also is a perpendicular bisector of LN. What is the value of X? This is a square. These are all congruent triangles. We can see side angle side. So all these sides are congruent. So 5x is equal to 3x plus 20. Take away 3x from both sides and divide by 2. We get 2x's is equal to 20. X is equal to 10. So the value of x is 10. Find the length of LM. LM is 3 times 10 plus 20. That's going to be 50. And LO also has to be 50. 5 times 10 is 50. Okay, let's look at number 5. How is TV related to SU? TV is the major diagonal of this kite. SU is what we call a minor diagonal. The major diagonal, the long diagonal, TV, bisects perpendicularly the SU minor diagonal. So we can say that TV is a perpendicular bisector of SU. Find the value of TS. TS is going to be 3.7. Find UV. UV is going to be 7.9. And find SU, the length of SU. If one part of it is 3, since it's bisected, the other part also has to be 3, which gives a total length of 6. Let's look at number 9. Let me blow this up a little bit. So I'm taking this as, it's talking about the entrance to the building. It says entrances. So I'm taking this and this to be entrance to the building. And it's asking, at which of the labeled points would a receptionist chair be equidistant from both entrances? So we're kind of looking for an isosceles triangle type pattern. So B would give us an isosceles triangle. And that's really it for the coordinates. So B would probably be the position for the receptionist chair to be equidistant from both entrances. Is the statue equidistant from the entrances? Well, let's check and see. Do we get an isosceles triangle if we connect it? Yes, we do. So I think, yes, the statue is also equidistant, and it has to do with isosceles triangles. Isosceles legs, congruent. Okay, let's look at number 10. So in baseball, the bases are 90 feet apart, which is 30 yards. And they're telling the shortstop that they want him back about, what do they say it? Back about 3 yards from the baseline. So they want him back, if his stride is 36 inches, which is 1 yard, they want him to pace back about 3 feet back from the midpoint of this baseline. So assuming that he has a stride of 36 inches, which is 3 feet, there are 10 paces that he could, 10 steps that he could do from second to third base that would basically cover the 30 yards, since each step is going to be 3 feet. Halfway would be 10 steps. 10 steps would be 30 feet. 15 steps would be 45 feet. And 45 feet would be halfway in between. So my suggestion would be that he takes 15 large steps from third towards second base. That'll find the midpoint. Then take 3 yards. Then take 3 steps towards the outfield. So that'd be one way of doing it with steps. And I didn't even think about that till they talked about the stride of 36 inches. My idea would be for him to kind of guesstimate where 9 feet back would be and try to check for a symmetry, try to check for a congruent angle from where he's standing towards each one of the bases. Like if he could look this way 30 degrees and this way 30 degrees and pretty much be on the bases, then he's pretty much in the center. So that would be an angle way of doing it, by dealing with the vertex angle being bisected. The other way to do it would be to kind of measure it out by doing the steps. If you have another idea, let us know. Okay, let's look at number 11. According to the figure, how far is A from CD? So according to this figure, A is 15 units from CD measured along this perpendicular. How far is it from CB? It's also 15 because of the symmetry. That side's also going to be 15. How is ray CA related to DCB? CA must be an angle bisector. So CA bisects angle DCB. And one way of knowing that is that a point on the angle bisector is equidistant from each one of the sides. So they're showing us that this point A is equidistant from the CD side of the angle and also from the CB side of the angle. So that puts A on the angle bisector. So that's how we know that CA is an angle bisector. It says find the value of X. Well, an angle bisector is going to bisect the angle. So these two angles are going to be equal to each other. So we can set 2x equal to 3x minus 29. Take 3 x's away from both sides. Minus x is minus 29. X is 29. So we get x is equal to 29. Find the measure of ACD. ACD is going to be twice 29. That's going to be 58. And ACB is also, what's going to be 3 times 29 take away 29, which is the same as twice 29, which is going to be 58. And those are degrees. Find the measure of DAC. Now, using triangle sums, if we have a 90 and a 58, that adds up to 148, and 180 minus 148 is 32. So DAC and BAC are both 32 degrees. Is 32 degrees. Okay, let's look at the next page. Number 16. Let's see what we got here. According to the diagram, what are the lengths of PQ and PS? According to the diagram, PQ is 10, so PS must also be 10. Now we can, PS is also 10 because these are marked as being congruent to each other. How is segment PR related to angle SPQ? SPQ is here. PR is perpendicular to the base. It's a perpendicular bisector of the base. So a perpendicular bisector to the base of this triangle is also going to be a perpendicular bisector of angle P. So we would say PR bisects angle SPQ. Find the value of n. These two angles are equal to each other, so we have 5n minus 20 equals 3n. Add 20 to both sides, take away 3n. 2n is equal to 20, n is equal to 10. Find the measure of SPR. SPR is 5 times 10, take away 20, that's going to be 30. And QPR, same thing, 3 times 10 is 30 degrees. Okay, let's look at number 20. We want to find x. So these two, AD and AB, are congruent segments. So if we set 5x minus 3 equal to 3x plus 1, we can find x. And take away 3x from both sides, add 3 to both sides, we get 2x equals 4, so x is going to be 2. BA then is going to be 10, take away 3, which is 7. And DA is going to be 6 plus 1, which is also 7. Zoom back a little bit. Let's look at the next one. We want to find x. These two angles are congruent to each other since this is a bisector. And so we can set 5x plus 20 equal to 9x. Take 5x away from both sides, we get 20 is equal to 4x, or x is equal to 5. So x is equal to 5. We want the measure of DEF. DEF is going to be twice 5x plus 20. 5 times 5 is 25, plus 20 makes 45. Twice that is going to be 90 degrees. So DEF is a 90 degree angle. That's it for that one. Let's look at number 22. This angle is bisected, so 3x plus 12 equals 5x. Take away 3x from both sides, 2x's is 12, and x is going to be 6. Now find the measure of DAB. D to A to B, that's going to be twice 5x, which is twice 30, which is 60. Take a look at 23. Find M. These two segments are congruent to each other since we have a bisector. It's actually going to be a perpendicular bisector. So M plus 1 is equal to 2M. Take M away from both sides. M is equal to 1. LO then is going to be 1 plus 1, which is 2. And NO is going to be twice 1, which is 2. And we found that M was 1. Looking at 24, we've got 3x equal to 5x minus 30. Take 5x away from both sides. Minus 2x's is minus 30. Divided by minus 2, x is 15. Now x is 15. The measure of QTS is going to be twice 3 times 15. 3 times 15 is 45. Twice that is going to be 90. So QTS is 90. Looking at number 25, they want us to find out what P is. These two sides are congruent to each other. So 4P plus 3 is equal to 3P plus 6. Take 3P away from both sides and take 3 away from both sides. We got P is equal to 3. So we get P is equal to 3. Now IJ is going to be 4 times 3 plus 3, which is 12 plus 3, which is 15. And KJ is going to be the same thing. That's going to be 9 plus 6, which is also 15. Let's take a look at number 28. So what we got here? We got 8r is equal to 5r plus 9. Take 5r away from both sides. 3r's equals 9. Divide by 3, r equals 3. So r is equal to 3. The length of UW is going to be twice 8r, or twice 24, which is 48. Looking at number 27, these two angles are congruent to each other. So we have 3y plus 4 equals 5y minus 10. We're going to take 3y from both sides, and we're going to add 10 to both sides. So we get 2y's is 14, y is going to be 7. So we got y is 7. DEF, which is this large angle at the top, is going to be twice the measure of each one of these bisected pieces. So we have 3 times 7, which is 21, plus 4 makes 25. Twice 25 makes 50. So measure of angle DEF is 50. Let's look at 28. Try to get a different color here. Let's see what we got. These two angles are bisected, so they're equal to each other. So we have 2p minus 5 equals p plus 5. So add 5 to both sides, take p away from both sides, we get p is equal to 10. P is equal to 10. Now we got to find m. 2m for this side is equal to 10 on the other side. So 2m's equals 10 and m equals 5. So m equals 5 for number 28 and p equals 10. Let's look at 29. Writing, determine whether A must be on the bisector. Now, to be on the bisector, if a point's on the bisector, it's equidistant from the endpoints of the segment, or from the sides of the angle. Endpoints of the segment, it's on the perpendicular bisector. Same distance from the sides of the angle, it's on the angle bisector. So they're showing here that this point A is equidistant from ML and MN, which are the sides of this angle LMN. So A is on the angle bisector because it's equidistant from the sides. So angle bisector. So it's on the angle bisector. Now let's look at this other one. They got A. They're showing that this angle and this angle are congruent to each other, which means that MA is an angle bisector. And we can see in looking at this that A is on this ray MA. So A is on the ray. So A is on the angle bisector. Okay, that's it for these. Thank you.